You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Genetically modified organisms. Jeopardy or Jackpot? Today we're going to look at one of the most divisive issues in global food production: genetically modified organisms. Supporters point to vastly improved crop yields and reduced need for fertilizers and pesticides. Opponents claim that such products are inadequately tested and may result in unknown dangers. Some poor developing countries, like the Philippines and some African nations, have become battlegrounds between the environmentalists and the farmers. Let's find out what both sides are claiming. So what exactly are genetically modified organisms, and how does genetic engineering differ from the type of artificial crop development that man has been practicing for thousands of years? Nature's method of genetically hybridizing plants is cross-pollination, and for most of human history this is how farmers and scientists have created new and improved species of crops. Plants can be hybridized quite readily, more so than animals, but there's still a limit to how far apart the species can be. The principal differentiator of direct genetic manipulation is that you can move individual genes from one species to virtually any other species, no matter how different they are. But more to the point, you can select specific genes that carry specifically desirable traits and accomplish far more significant improvements with much greater control in much less time. The first commercially available genetically modified organisms were in medicine. The first widely produced GMO was synthetic insulin, which was approved by the FDA in 1982, and is how all medical insulin is now produced. Human growth hormone used to have to be taken from cadavers, but through GMO, it's now produced synthetically. The vaccine for hepatitis B was developed through GMO in 1987. Genetic engineering is also responsible for the oil-eating bacteria used in industrial applications. When designing improved food crops through traditional hybridization, one of the principal barriers is that the new offspring are often sterile, particularly when the species being cross-pollinated are too far apart. Through GMO hybridization, this barrier can often be overcome. And when it comes to food crops, the idea is to take the strengths of one plant strain, such as an immunity to a certain disease or a hardiness to certain adverse conditions, and transfer that strength to another plant strain that needs it. One example that researchers are working on now is immunity to the rust fungus, a fungus that affects all cereals, but for some reason rice is immune to it. If that immunity can be given to other cereals like wheat and barley, then we have a better crop that is resistant to one more disease. Yields go up, and the need for chemicals to eradicate the fungus goes down. Everyone wins. In 1943, what became known as the Green Revolution began when Mexico, unable to feed its growing population, shouted for help. Within a few years, the Ford and Rockefeller Foundations founded the International Rice Research Institute in Asia, and by 1962, a new strain of rice called IR8 was feeding people all over the world. IR8 was the first really big modified crop to make a real impact on world hunger. In 1962, the technology did not yet exist to directly manipulate the genes of plants, and so IR8 was created by carefully crossing existing varieties, selecting the best from each generation, further modifying them, and finally finding the best. Here is the power of modified crops. IR8, with no fertilizer, straight out of the box, produced 5 times the yield of traditional rice varieties. In optimal conditions with nitrogen, it produced 10 times the yield of traditional varieties. By 1980, IR36 resisted pests and grew fast enough to allow 2 crops a year instead of just 1, doubling the yield. And by 1990, using more advanced genetic manipulation techniques, IR72 was outperforming even IR36. The Green Revolution saw worldwide crop yields explode from 1960 through 2000. No discussion of GMO is complete without a mention of Norman Borlaug, the 1970 Nobel Peace Prize winner, 1977 U.S. Presidential Medal of Freedom winner, 2006 Congressional Gold Medal winner, and best known as the father of the Green Revolution. The unanimous act of Congress states, Dr. Borlaug has saved more lives than any other person who has ever lived, and likely has saved more lives in the Islamic world than any other human being in history. The Nobel Committee put a number on this, estimating that he was personally and directly responsible for saving over 1 billion human beings in the Third World from starvation. Dr. Borlaug did it by pioneering the use of hybrid and genetically modified crops, designing new strains that could thrive in arid conditions where pesticides or herbicides were not available. He's also known for Borlaug's hypothesis, which proposes that the best way to reduce deforestation is to reduce demand for new farmland by using our best existing farmland to its maximum potential. GMO crops also give seed manufacturers capabilities with potential to be less benevolent. By employing what are called terminator genes, manufacturers can theoretically exercise patent enforcement techniques not too different from software activation. You can grow the plants fine, but the engineered traits require chemical activation, thus enforcing annual license fees from farmers. However, terminator features can also be used to address the concerns of anti-GMO activists worried about cross-pollination and contamination. Crops can be engineered to produce sterile seeds, or to produce only sterile offspring should cross-pollination with conventional crops occur. When we turn our skeptical eye toward the Philippines, we see Greenpeace activists wearing full biohazard spacesuits, cutting down GMO crops and disposing of them in sealed containers. By inviting reporters and photographers to document these demonstrations, they very effectively spread terror among the undereducated, poor Filipino public. Now, I think any reasonable person agrees that you wouldn't do such a drastic thing without very good reason. So there must indeed be very good evidence that GMO crops are only safely handled by hazmat disposal teams. Wouldn't you think? Let's look at Greenpeace's website and see what frightening information they've uncovered. The production of unexpected toxins and allergens. Because genetic engineering is a very imprecise technology, the insertion of foreign genes can stimulate the production of unexpected proteins, which may prove toxic or allergenic. First of all, it's hardly a very imprecise technology. Gene manipulation requires great precision and produces far more precisely designed results than can be hoped for with simple cross-pollination. The very purpose of the research is to avoid toxic or allergenic results. When these results are found in GMOs, those products are not sent to the market. Duh! A large part of science involves learning how to make things better. Do we stop all scientific research in every field because learning how to make things better also teaches us what makes them worse? What a ridiculous objection. Antibiotic resistance. Scientists add genes that confer resistance to common antibiotics. What they meant to say is that some GMO research seeks to find ways to make crops resistant to harmful bacteria by incorporating the right toxins into the crop, thus eliminating the need to apply that toxin separately in the form of synthetic or organic pesticides. Yes, people, organic pesticides contain the same toxins found in synthetic pesticides. They have to, otherwise they wouldn't function. Finding ways to manage this process to avoid creating resistant pests has been a major area of study in farming science for centuries. This is a farming problem that exists independently of GMO. GMO neither creates nor exacerbates this issue. Effects on the environment. Genetically engineered crops represent new and potentially invasive forms of life. All plant species are potentially invasive. And that's why farmers use good management techniques. There's no reason you should be expected to do this any more or any less with GMO crops, as you have always had to do with all crops. This criticism says nothing about GMO. Contamination of seeds and crops. People are still increasingly finding even non-GE stocks contaminated. This is due to cross-pollination where contaminated pollen is carried by wind or as seeds spread out in the environment or are mixed up during handling. This has always been true of all plants. Cross-pollination has nothing to do with GMO. It is responsible for all the biodiversity of plant life on the planet. Calling it contamination is simply using a weasel word to raise alarm about a perfectly natural, normal process. GE foods remove consumer choice. Because of the widespread contamination caused by GE crops and the fact that many GE crops are not kept separate in the food system, consumers in the Philippines have been denied the right to choose not to eat genetically engineered food. Again, this has always been true of all food crops. Virtually all modern food crops, cereals, corn, rice, are the result of human hybridization. Is Greenpeace applying this criticism to all food crops, or only to those developed by for-profit companies? Is this a scientific objection or an ideological objection? Biopiracy. In order to achieve the desired traits, chemical companies often use genes acquired from plants, animals, and bacteria found in poorer countries. In effect, these genes are being stolen from the poor to feed corporate profits. And what is Greenpeace's most frequent argument in favor of maintaining Brazilian rainforest? The forest, says Greenpeace, acts as a crucial medicine chest for pharmaceutical advance. When it serves their purposes, Greenpeace is all in favor of using substances from plants in poor countries. But when someone else does it to feed people, suddenly it's biopiracy. This is the height of hypocrisy. Increasing knowledge by studying genetics in a different country is good for everyone. Is this really the best Greenpeace can do? Loss of farmers' rights. Because genetically engineered seeds are patented, the seed company can maintain strict control over how the seeds are used. This is true of all patented products in the world. Even Greenpeace retains strict control over their legally protected properties, profiting from t-shirt and bumper sticker sales, and prosecuting those who violate their copyrights. This is yet another hypocritical and irrelevant argument that has nothing to do with the science or safety of GMO. Genetic engineering is unnatural. Because genetic engineering creates new living organisms that would never naturally occur, many people hold moral and spiritual objections to it. Finally, an honest and factual objection. There's nothing at all wrong with having moral and spiritual opinions. What is wrong is calling them science and using them to deny food to poor people to whom your spiritual notions may not be as important as feeding their starving children. And yet, these are the best reasons Greenpeace can come up with to defend the act of terrorizing Filipinos by raiding their farms wearing hazmat suits. I'll conclude my discussion of GMO with a quote from Norman Borlaug, who says it better than I could. Some of the environmental lobbyists of the Western nations are the salt of the earth, but many of them are elitists. They've never experienced the physical sensation of hunger. They do their lobbying from comfortable office suites in Washington or Brussels. If they lived just 1 month amid the misery of the developing world, as I have for 50 years, they'd be crying out for tractors and fertilizer and irrigation canals and be outraged that fashionable elitists back home were trying to deny them these things. A call to all students and young people who listen to Skeptoid. I'm going to be answering your questions on some upcoming shows. Ask me what I think of Bigfoot, UFOs, numerology, or anything else you want to know about. I'll explain how to use skepticism and the scientific method to find our best answers for the biggest questions. To record and send your question, come to Skeptoid.com and click on Answering Student Questions. That's Skeptoid.com and click on Answering Student Questions. I look forward to hearing from you. You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com.